So now that we've seen where the product rule comes from, I want to talk about a couple situations in which the product rule can be used. Now, identifying a situation where the product rule can be used is simply a matter of identifying that you have a product of two different factors being multiplied together. So in both of these cases, you'll notice that because they are polynomials, we could simply expand the polynomial and make use of the sum, difference, constant, multiple, and power rules. However, given that we're trying to gain a little bit of experience with the product rule, I'm going to stick with the product rule for this. So the product rule states that in order to differentiate this product, we take the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Sort of a little back and forth thing. Now, the product rule doesn't complete the derivatives for us, but it should give us some more elementary things to differentiate. Now, both of these elementary things are linear, and as such, the derivative of something linear is simply going to be its slope. So for the first one, 2x plus 5, that will become 2, and for 5x minus 3, when we differentiate that, we will get 5. Now you may recognize this from a previous video. In a previous video we did expand this and differentiate it. Let's see if we wind up getting the same thing when we expand here. That'll be 10x minus 6 plus 10x plus 25, and when we combine like terms, that is 20x plus 19. Indeed, we did get the same result as in the previous video. Now for this one, again, we could expand this thing completely and then differentiate it, but we want to practice the product rule. So product rule, once again, states this will be the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. Oops, that should be d over dx of x plus 3. Okie dokie. So, applying the power rule, as well as the constant multiple and sum and difference rules inside this set of parentheses, derivative of x squared is going to be 2x. Minus 3x will become minus 3, and plus 9 will become plus 0, as it is a constant term. This part stays the same, and then the derivative of x plus 3, again, this is linear, so that'll simply be the slope, which is 1. Next up, I'm going to expand x plus 3 times 2x minus 3 so that we can worry about combining like terms in just a moment. So that'll be 2x squared, outer gives us minus 3x, inner gives us plus 6x, and last gives us minus 9, plus x squared minus 3x plus 9. Combining all the like terms that we see, I see that we have 2x squared plus x squared, that is 3x squared. I see a minus 3x plus 6x, those will cancel, and minus 9 plus 9, those will cancel as well. So that is the use of our product rule. It wasn't necessary to use the product rule on these problems because, again, we could use algebra to expand and then differentiate using more basic rules, but it will become necessary in the future once we start bringing in more different kinds of functions like exponentials and logarithmic and trigonometric and those sorts of functions.